So this is what we've got going today. We got Chapter 2 final review. The objectives we're looking at, gentlemen, shh, thank you. The objectives we're looking at is reasoning to make conjectures, recognize conditional statements and their parts, write converses, inverses, and contrapositions of the conditionals, write biconditionals, and recognize good definitions. Use the law of detachment, law of syllogism, connect reasoning in algebra and geometry, and prove and apply theorems about those angles. Now, first thing we're going to get to is if-then statements, okay, our conditional stuff. So learning objective students will be able to recognize conditional statements in their parts. Identify the conditional statements below. Now, the conditional statements have if and then in them, okay? They're not just statements. They're conditional statements. If this, then that. Now, the first most obvious one that people always see is this one. But that's not the only one. Hypothesis follows if. The conclusion can be preceding if. Okay? So this is also an if-then statement. These are if-then statements. The other ones are just statements all by themselves. Okay? Now, as we're reviewing these if-then statements, identify the hypothesis and conclusion. Q, hypothesis P, conclusion Q, as we look through this. If you have a calculator, then you won't have to borrow one from Miss Scotia. Well, this first part, my P, is right there. So that's my P value. My Q is right here. Okay, that's my Q value. And so I will be just writing those straight in. I will not include if, I will not include then. Now, it's your turn. You guys determine your hypothesis P and conclusion Q in the statement. You know who Rick Grimes is if you watch The Walking Dead. And be careful. Hypothesis follows if. Hypothesis follows if. That way people won't kill themselves. Thanks. So, the hypothesis, you watch The Walking Dead. That's my hypothesis right there. That's my P. My conclusion, you know who Rick Grimes is. Okay, that's my Q. So those are the two things we should be doing. Are you okay with how I found them, how I identify them, and their position? It's all about position when we're talking about if-then statements. Hypothesis, conclusion. We're good? Okay. Now, sliding on here, I'm just making sure people are done writing. When we look at these, I have converses, inverses, contrapositives of conditionals, and the original conditional. I've talked about them. I define them using P and Q. You don't have these statements in yours, but I'm going to put them in each one of the ones we work with. And each time, the original statement, if this is the original, it is P implies Q. Okay, so now, if the Seahawks win the Super Bowl, then they will make up for their loss 2 years ago. Okay, this is a statement. The converse switches the hypothesis and conclusions positions. So when I switch those positions, if the Seahawks make up for their loss 2 years ago, then they win the Super Bowl. Notice how I use the term they for Seahawks, and I swapped them. I left Seahawks to be in the front so people knew what we were talking about, the subject, but then I changed the other stuff for readability. So check that out. Write that down on this. Okay, you guys are on this one. You're writing it down, so get it done. inverse. Inverse negates the hypothesis and conclusion in their same positions. A negation either puts in a not or removes it, okay? So in this case, I'm looking at the inverse, and it's always on the original conditional statement. If the Seahawks do not win the Super Bowl, then they will not make up for their loss 2 years ago. Okay, so the change, do not win, and on the will not make up for their loss 2 years ago. Please notice how I did that. So my last one is called the contrapositive. The contrapositive, that not Q implies not P. You see how I look at that tilde, that wavy symbol in front of the letters? Then those are nots, okay? And we're negating the hypothesis, we're negating the conclusion. So that, and we switch them. So now I have the conclusion first negated, and then the hypothesis second. And that's the difference between the inverse, converse, and contrapositive. So look those over, and now we're going to take a minute after we get that down, and you guys will write the converse of the statement. If it gets too cold, then we will have a snow day. So you will write the converse of that statement. So the converse becomes, if we will have a snow day, then it gets too cold. Remember, converse switches the hypothesis and conclusion positions. The converse switches the hypothesis and conclusion positions. So that's why it's Q implies P. And this is my original statement, by the way. This is P implies Q. So now looking on, my inverse negates, and everything stays in the same position. So I go not P implies not Q, so I go back to the original. If it does not get too cold, then we will not have a snow day. I'm not asking you to evaluate whether it's true or false. I'm asking you just to write the statement. I am not asking you to say it's true or false. I'm just asking you to write the statement. And my last one, contrapositive, it's a negation switch. It's a contrapositive, is a converse inverse, the contrapositive is. So I negate and switch. If we do not have a snow day, then it will not be too cold. Are you doing okay with these? Are there any clarifications? And it's all about position. Now, there's one more thing in here that we can talk about, and that's a if and only if statement. An if and only if statement is true when the original statement and its converse, or the original statement being the forward statement and the converse being the reverse statement, are both true. You can write a true biconditional using if and only if in place of the then and just dropping the if. If you write a biconditional, okay? Good definitions can be written as biconditional statements. As we slide on. Learning objective students be able to connect reasoning and algebra and geometry. Identify the property being used. If x is equal to 5, then 5 is equal to x. This is an example of symmetric property. So this was my question, and this is my answer. So in 1, what am I doing? I got that distributive property going on. Okay, I'm going to distribute from this part to this part, so I've got distributive property. In 2, if x equals 3 and 3 equals y, then x equals y. This is an example of transitive property, and that's of equality as well. The first 3 were all of equality, and they all have equal signs in them. This next one, I've got segment AB congruent to segment AB. This is reflexive property, something that's equal or congruent to itself. In this case, it's congruent, so it's reflexive property of congruence. And that's the difference between properties of equality and properties of congruence. Properties of equality are inequality. Properties of congruence are incongruence. I can't add, subtract, multiply, and divide things that are congruent, but I can use those as equality. So adding, subtracting, multiplying, dividing are property of equality. I do not use them in congruence, so they don't exist in congruence. In 4, I'm going from 2x plus 2 equal 8. I did something, and it became 2x equals 6. Did you see I've subtracted 2 from both sides? That's why I can say it's subtraction property of equality. In 5, I went from 5x equal 15 to x equal 3. I divided from both sides, so that's division property. And in 6, my last one there, I have something called commutative property. X plus 3y is the same as 3y plus x. And that comes from the idea is the distance from home to work and the distance from work to home is the same. It's morning commute, afternoon commute, provided you don't have any detours or you don't decide to go someplace else on your way home. Okay, and that's property identification. Okay. Now, how do I do algebraic proofs? Now remember, an algebraic proof is just you telling or describing what you're doing on each step, okay? You're just describing what the result is. You find a result and tell, hey, this is what I did. So I always start with the given, so get your given on, maybe. I can start with the given. I always start with the given. And the first thing I'm going to do is get rid of that parentheses. I'm going to get rid of the parentheses. They're gone first. After I get rid of the parentheses, that's the distributive property, I have 4 ways to finish out my problem. I don't care which way you decide to go to first. I have 4 ways to finish out my problem. I decided to subtract 4x from both sides. So subtraction property of equality. Then I went to adding 20 to both sides. Addition property of equality. In doing this, however, I flip-flopped what I was asked to solve for. Do you see they asked me to prove that x is equal to 30? And right now I have 30 is equal to x. I have one more step to do, and that's something called symmetric property. I'm just going to flip it. X equal 30. And symmetric property is only used to do that, and that's it. Are there any questions about how I went about this? Now, in the next screen, we will be looking at a proof of vertical angles. Okay, vertical angles are congruent, but here's the thing. When we do a proof on a property, we cannot use that property in the proof. Okay, that's the same way as you testifying, and after you're done testifying, you come up and corroborate your own testimony. So, oh yeah, I said that. Yep, I said the truth. Yep, no problem. I was with me. Okay, I'm my own alibi. Okay, they would look to alternative outside sources other than yourself to make sure your testimony was truthful or not. In this case, when we prove, in the case of the vertical angles, we cannot use vertical angle property. We can talk about them being vertical angles, but we can't talk about the property that vertical angles are congruent. We're proving that, okay? So in order to do that in this next one, I'm going to write down the given that 1 and 3 are vertical angles. Okay, that's given. I don't know anything more than 1 and 3 are vertical angles. I do know, however, based on the picture, that 1 and 2 are supplementary because they're a linear pair. I also know that 2 and 3 are supplementary because they're a linear pair, or better yet, I should say both of those can be added up to 180. So I got my given, and I've got my linear pair stuff. And because of linear pairs, I know the measure of angle 1 and the measure of angle 2 are 180, and the measure of angle 2 and the measure of 3 are 180. Now, keep in mind what I'm doing. The purpose of this is for me to show that measure of angle 1 and the measure of angle 3 are actually equal, and therefore congruent. At this point right now, I'm going to substitute. And this is my substitution. I know both of those are equal to 180, so I can set them equal to each other. In doing so, I get to subtract the measure of angle 2. So the measure of angle 2 is no longer something I need in the problem. I'm going to subtract that out by subtraction property of equality. Right now, I'm saying that the measure of angle 1 is equal to the measure of angle 3. Well, one thing allows me to go from congruence to equality, or equality to congruence. And in this case, we're in equality, we're going to congruence. So I can finish with this relationship, and it's going to be by definition of congruent angles in this case. But definition of congruence would have been fine for you just to set it that way. Now, I'd like you to take the next minute and a half and answer the next 2 questions below this problem. They are angle measure questions while I take attendance. Sorry, you were on the wrong page. I was like, that's not what we're doing next. You're fine, Levine. Kind of threw me for a loop like I missed something. Okay, so you're all good. All right, so let's look at this. Measure of angle 1 and measure of angle 3, we just found out they're the same measure. But so is 2 and 121. So 2's got to be 121 degrees. 1 and 121 and 3 and 121 are supplementary. So 180 minus 121, if I go 180 minus 121, that's going to give me a 59, and that is the measure of angle 3 and angle 1. Are you okay with those? My next one, supplementary angles are adding to 180. Complementary angles are angles that add to 90. These are supplementary, so 135 is subtracted from 180, and I get 45 degrees. Are there any questions? Now, what I'd like to do is fill out your summary on your notes. Okay, what you may have picked up differently. You know, write a couple of sentences about something that you learned differently today about the learning objectives, and then rate yourself from 0 to 4 about your preparation right now. And remember, your job today is not just reviewing your notes, but making sure you get after your Quizlet so you know the words better. Go to the Chapter 2 review questions, answer those. If there's something that's given you a difficulty, you're getting it wrong, you got to ask a question. And then make your Chapter 2 note card better. Okay? Make it better than what it is right now, so you can benefit from this work. Okay? Now, good luck. Make sure you use your time, and we'll see you tomorrow.